So, welcome everybody. This is really exciting. This is one of the first times that Secret Network is doing a developer workshop like this live, where we're going to be able to have a collaborative experience working and building together. Today, you're joined by myself, Conrad, as well as Ertemann. Ertemann, you want to say hello and just do a quick intro?
Yeah, of course. Hi, everyone. Ertemann, also known as Thijs, I'm from the Netherlands. I've been working in Secret as a developer relations lead now for over a year. One of the co-founders of the Secret agency. So Chris, my colleague, and Conrad as well. We're pushing a lot on developer events. So very happy to welcome you here. This is one of the first, but I have many more in the coming months, including a hackathon. So stay tuned for that. But more on that later.
Awesome. Yes. So I also am doing DevRel for Secret Network. And what we're going to be building today is a decentralized business card application. And we're going to be going from the very beginning, from just downloading a just general contract repo, cloning that, and then all the way through to writing our smart contract and then uploading and instantiating and even executing our contract with secret.js. So hopefully by the end of this tutorial, you're going to have all the tools you need to be writing and developing your own smart contracts on Secret Network. So a little bit about me. I found my way into Web3 sort of just, I think just hearing about Bitcoin, seeing number go up. And then eventually I was like, I should probably read this white paper. And once I did, it was like, there was like a before version of me and an after version of me. And then I just started learning to code, just kind of fell face first into Web3. And I started with Ethereum because that's kind of just like what seemed available, seemed out there. To learn Solidity, I learned JavaScript and then had my first experiences really developing at like Ethereum hackathons. So I did ETH NYC last summer. And then from there, my hackathon team did Hack FS, which was a month-long hackathon. And it was there that I built a ZK DAO. So, ZK is one form of privacy technology. And we won a prize from Filecoin, but it was sort of like an unusable decentralized application. Honestly, it was just like a horrible user experience. And I thought like, if anyone's ever going to actually use privacy tech, there must be another way. And this just didn't feel like it. And from there, I basically just started Googling around and came across Secret Network. And once I started reading about the privacy tech, about the trusted execution environment, which we'll get into in a sec, um, I was like, okay, I guess I'm going to learn Rust now so that I can be a part of this community. And my developer journey from there to now is just that I did something called the Web3 Builders Alliance, which is super cool. You should check it out if you're like thinking about learning Rust and becoming a Cosmos developer. And for that, I built a decentralized business card application on Secret Network, was my capstone project. And so what we're going to be working on today is sort of like a stripped down, simplified version of that app that specifically is just looking at the use case of viewing keys on Secret Network. And yeah, what this app does is it's a way to create a business card on the blockchain where if you create a business card and if you want to, whoever you give it to, when you update that business card, everyone who you've provided specific user access to, it updates for everyone who has access to your business card. And the whole idea for this, the reason I was inspired by this app is I live in New York City. I moved a bunch. So my grandma kept sending me packages to old addresses. And so I was like, what if I could onboard my grandma to Web3 and, figure out a way for her to like maintain my address? And so my grandma is not onboarded to Web3 yet, but I still believe that it will happen. So as we dive into this, just make sure if you haven't already to configure your environment. All of that information should be provided in the Eventbrite that you guys signed up for. And if anybody needs any help doing that, just post in this main stage chat so that Erdemann or somebody else who's moderating the chat can get you that info. So for anyone who's like just brand new to Secret Network, I want to make this accessible to everyone at all levels. Because not even that long ago, Secret was totally new to me, and it was foreign. And the more you dive in, the more there is just like endless opportunities to learn. So it's the first blockchain with data privacy by default. allowing you to build and use applications that are both permissionless and privacy preserving. So basically, it's just a way. It's a network where you're able to write smart contracts where you're choosing who you share your data with and how. And it's in a way that's accessible to smart contract developers and to users alike. And in my experience so far, I have not found anywhere in the cosmos, literally and metaphorically, that is a better place to develop privacy preserving smart contracts. And for anyone who's like just totally new to Web3, like what's so exciting about Secret Network is, in this push to Web3 to decentralization, we didn't have to, rely on data providers, but in that we lost privacy because a blockchain is just a public ledger. So every transaction on Bitcoin, every transaction on Ethereum is data that is, accessible to the public as soon as somebody knows your wallet address. Like, I don't know if you guys were following when the FTX fallout happened. There were just like Twitter threads galore of people's wallet addresses that were like linked to their personal identities, and the amount that they lost to the FTX crash was like public knowledge. But if like that had happened on Secret Network, if people's money was in SNP 20s, which is the privacy token of Secret Network, that wouldn't have been the case. And this is the whole reason I came to Secret Network to build this business card application, is because like obviously our personal information, your home address, your phone number is not information you want to be accessible to anybody on a public ledger. And what's so incredible about Secret Network is that there is a way to create this data and have it in a way that like no one has actually seen it. It's all happening in something called a TEE. This is a trusted execution environment. And it's sort of just like a black box for data processing. So you can think about it in the way that like when your smartphone, when your iPhone uses your Face ID, all that information is just being processed on a chip, and the phone itself doesn't actually have access to that information, that private information that is being stored. Um, and so this is what allows Secret Network to make these encrypted transactions. So like as this says, that not even the nodes operating on the network can access the information that is being decrypted and processed. It's only the smart contracts and the logic that we're going to be programming into the smart contract we do today that has access to that information. So one thing to note is there's a couple of different ways on Secret Network that you can provide access to users to have access control of their information, namely like viewing keys, and then also query permits is another methodology. But today we're going to be focusing specifically on viewing keys for access control. And the way we're going to be doing this is essentially, and we'll talk about it in more depth as we go along, but with every business card we create, we're also going to create with it a unique viewing key. And so then when we share that viewing key with people who we want to have access to our business cards, only people who have the viewing key are able to access the smart contract and access that business card that is uniquely associated to that viewing key, as well as the creator's wallet address. So the way viewing keys are constructed is using something called the secret toolkit. And so if you're new to Secret Network and you're coming from, say, another Cosmos blockchain, what's awesome about Secret is that it's completely compatible with other CosmWasm smart contract blockchains. So like if you wrote contract on Juno, you would be able to port over a lot of that functionality to Secret Network. You'd have to change a few things like with storage. But coming to Secret, you have all of these access to additional toolkits, which is what Sandman just posted in the chat. Secret Toolkit Heart. Definitely check out that repo on GitHub and give it a star, give it a favorite, because you will be coming back to it incessantly. But part of this toolkit that we're going to be using is this random number generator. And this is how we're able to create these viewing keys and have this unique, access on Secret Network. So yeah, each viewing key, it needs entropy, and we generate that entropy using Secret Network's RNG generator. Does anyone have any questions so far or any thoughts about what I've said thus far? All right. I love it. Polite group. Just let me know. I want this to be a collaborative experience. I don't want you to feel like I'm just talking at you. And there's no dumb questions. I'll probably have dumb answers, but there's a lot of brilliant people in this chat who are developers on Secret Network who I think will be able to assist in answering your questions. So at any point, just feel free to jump in and ask questions. So the main functionality that our contract is going to have is the ability to create a card, and it's going to be at a specific index, as well as burn a card. So delete the card at that index, and then also generate a viewing key. Right now, this is kind of just like a bird's eye view of what we're going to be developing. This is the viewing key function that we're going to be looking at today. So we'll look at this more depth, but I just wanted to kind of comment out this code line by line for you to understand like how cool the secret network RNG generator actually is. So like this line right here, let mute RNG. So this is where we're accessing the secret toolkit to generate this RNG. And this function, new viewing key, this is a lot more complicated than it has to be because the secret toolkit actually like simplifies this with generate viewing key functions. But I just kind of wanted us to also be able to like take a look under the hood of what we're actually doing, and seeing like how a viewing key is actually randomized. So like, yeah, it's like it's accessing like the user's wallet information, which becomes a component and like block time and things like this. Like right here, this line right here, environment block time. It's accessing things like in real time, like the user's wallet address and block time that is then, used to generate this random number to generate a viewing key. And then the second component of this workshop is we are going to be working with secret.js to actually upload and instantiate and execute and query our smart contracts. So the first part of this workshop, we will create the contract together, and we'll do everything up to the burn card functionality, which we'll then break into small groups. I'll let you guys do that. We'll also take probably like a 10-minute break at the midpoint, just so we can use the bathroom or get food. And then the second half of the workshop will be focused on using secret.js to upload, instantiate, and execute our smart contract. And the way I've designed this is I want us to like go through this sort of step by step together so that like if you're new to developing on Secret, you have all the tools you need to like figure out where everything is to be able to develop your own contracts. So like, for example, when we go to do the secret.js component of this workshop, we're actually going to go through the secret.js docs and be pulling stuff from those docs into our JS file, chunk by chunk, just so that you understand kind of like, we're not just copying and pasting from a repo. This information all exists somewhere and you have access to it. All right. Let's see if this works. Cool. So what we're doing, this is just a demo of what the dApp actually is. So this is just a simplified version of the dApp I created. The dApp I originally made has like a QR code component where you're able to share the viewing keys with QR codes and query permits. And it just kind of streamlines it more, but I wanted just to strip this down to the barest components so that we like really understand what we're doing. So all that we're doing, right, is creating the card and then being able to share that card with the wallet address if they have the correct viewing key. Let me just make sure my wallet address is connected. Okay. So like, for example, my name, Conrad, I live on Elite Secret Lane. I have a phone number and then the card number. This is what's associated with the index. We save this card. We execute this transaction. So when we're doing this, what's actually happening behind the scenes is our front end is calling both the create card and create viewing key function simultaneously, which we're going to be building out today. So I approve this transaction. And then what should happen is that I should receive a viewing key that is unique to that card, which right now it's just in my console. So then when I go to query my cards, I need that viewing key. I need the wallet address that created the card. So that's just my wallet address. And then the card number, which is, again, that index that the card is associated with. And if I save that, if I have the correct information, then my card should be returned. And so this is a card that is stored to the smart contract that we're going to write today, right? I really hope this kind of just like springboards thoughts for you guys of like applications you can make on your own. Um, Trying to think if there's anything else I should note for this. Oh, the other thing to note, I guess, is that this is all happening on the secret.js, the secret testnet on Pulsar testnet. So like if you were to use this contract code, the contract address, you would have access to this as well and be able to use this right now and create cards using this contract. Um, is there anything else? Ertemann, is there anything else you want to add before we dive in?
No, I think I will give some more context about what other applications you can think about or what you can all make with secret contracts later on at the end of the workshop. Basically, we'll dive into that. So I'd say if there is no question about sort of the functionality of the application, we're ready to get started. Right? You're
Awesome.
going to give a quick rundown of the sort of code template first, right?
Yeah. Yeah. Does anyone have any questions before we move forwards? Cool. Just keep them coming, keep posting in the chat, and we will be monitoring that. So yes, I want to take us from 0 to hero, which means we're going to start with just like a template secret network contract. And from there, build out our business card application. So this is just a great resource, which I want you guys, make sure you guys know about. It's called Secret University. And this is kind of like the forefront of pushing secret network knowledge out there right now. They have all these tutorials for you to learn. There's and it's like in-depth looks into contracts and then also how to connect them to front ends. And probably what we're going to be doing as we progress in the next few months is like actually kind of doing what we're doing right now is building out workshops and video content that is showcasing what exists on Secret University. So yes, and Fuzzy just linked that in the chat. So definitely give this repo a star. Um, so if you want to follow along with me, you can do that. That might be cool for you to do that. I'm going to post this into the chat. I'm literally just going to clone this repo, pull it down, and get started. So just give me 1 second here as I clone this down.
Just for anyone else, by the way, for the break room soon, if you don't really think you would have to clone instead the repo, you already shared in the event, right? If you haven't yet, then I'll post the link again in the chat.
All right. All right. So has everybody seen my VS code? Cool. So what this is, this template contract, this is just kind of a starting point for developing our own contracts. And the main components that make up a CosmWasm smart contract, a secret network smart contract, is this message.rs file, this state.rs file, and this contracts.rs file. Message RS is like what we're actually executing in the contract. So these are the messages that we're going to be doing. So for example, this is a counter contract. So all that it's doing is it can increase a count by 1, or it can reset the count to a number. And like I said, in the intro to this dApp, what we're going to be doing is creating a card, burning a card, or creating a viewing key. So yeah, these are the main messages. Just think about like this is just the actions that your contract is going to be doing. And then also what the contract can do is query. And this is a separate part of a separate execution message. So like, for example, when we queried the card that we created, we executed the transaction with my Kepler wallet. Then in order to actually query that card exists at that given viewing key and index and associated with that wallet address, we had to call a query function. And so that's what we're going to be writing out here. And every query message returns a response. So that's why we have to create this response struct. Um, the state is just, you can think of as just like the database of your contract. This is where the information is actually being saved. Um, so for this contract, all that it has is the state of account and an owner. Um, and then lastly, the contract is where all of the logic is actually happening. So we have these various messages that are sort of the logical grounding of our entire smart contract. There's the instantiation message. We have these execution messages, and we have these query messages. And each of these points in the contract, these entry points, oops, they mirror our message.rs file. We have, right? We have an instantiation message, we have an execution message, and we have a query message. And if you're brand new to writing secret smart contracts, I think it helps just to understand that those messages logically flow into these contract entry points. So again, in this execution, we have increment and reset, and then we have functions that lay out the logic for those messages. All right. So the next step for us is to just dive in to tearing apart this contract and updating it for our contract. I'm probably going to do a mix of uh, writing it from scratch right now while also pasting in pieces that I've already written just for time's sake, but we'll see. I think it's more helpful to just like go piece by piece so that you're like understanding how everything flows together. I'm going to take a sip of coffee. Does anyone have any questions before we start tearing apart this contract? Cool. So because the message file, msg.rs, is these are the execution messages of the contract, because this is like what the contract's actually doing. I just feel like this is always a good place to start working on your contract, to be like, what do I actually want my contract to do? Right. So for our purposes, we said we are creating a card, and in that card that we're creating exists at an index. We are burning a card, and we are generating a viewing key, which also happens at that index. Um, for and then for our query message, we need to be able to return the card that we're creating. So instead of getting the count, we're going to be getting the card. So like part of the reason I think it's helpful just to see us like start with a counter contract and then go into our own functionality is you can see how like something that's like so simplistic or stripped down can actually serve as the structural outline for exactly like whatever you want to create or build on Secret Network. And so, yeah, each card is associated with a viewing key, which is a string. And for each of these query messages that we create, they have to be able to return a response. So, when we were querying the count, we returned a count response, which was just a struct with uh, this variable, this count variable. Instead, what we want to return is a card. And if you're like, where the heck is the card? The card is going to be defined in state, which is the storage component of our contract. And we will get to that part next. So just bear with me. So instead of a count, we have a card. And the other thing we need to be able to return is a viewing key response. So let's just add that. And like so much of this is just reusing these templates that are already defined for us in Cosmwasm and in Rust to build out what we need to be able to build out. Um, so if we have a viewing key response, and instead of returning a card, we're returning a viewing key. And if you're like an elite smart contract developer and you're watching me do this right now, I may blessings be upon you. But I feel like if you're new or this is foreign to you, I really hope this is helpful. Okay. And we have this instantiation message, right? So we said that there's these 3 entry points to our contract. There's the instantiation, there's the execution, and then there's the query. So instead of having a count, what we have, and this is unique to Secret Network, is we have entropy. And so this just ensures, this is just a variable that we instantiate our smart contract with that ensures the contract has true randomness. Ertemann or Sandman, do you want to like add anything to like what entropy is and why it's important to instantiate it for a smart contract?
Yeah, happy to. I guess, yeah, I posted a quick link in the chat. So if people are really interested, they can read that thread. But the gist of it is that blockchains are deterministic by nature, right? So on-chain randomness doesn't really exist because everything, by definition, is meant to have a determined state. So how the protocol solve this is they use off-chain APIs to obtain randomness. For example, Chainlink has this VRF oracle, which allows games to calculate hit splats or do casino games or whatever. But on Secret, just all of these validators actually share a piece of entropy, and this piece of entropy is what's used to create the encryption keys for Secret. And this piece of entropy is always protected, right? Because it's inside of this trusted enclave of these validators. So as long as you can create a protocol that sort of derives randomness from that entropy within the validator states, you're able to create a random number on chain. And there are some attack vectors, so you have to like properly defend against those attack vectors. And there's a second version of this sort of randomness API coming soon. This is part of privacy as a service. Yeah, but it's a really cool concept that you can basically use secrets to get a random number, and you can use this from any chain if you want to.
Awesome. Thank you.
And
Ertemann
for
is the
the
master.
question
Oh,
by
yeah.
Lexi, what does entropy mean? Entropy is sort of it's a bit hard to explain for me in English, to be honest, because I'm not a native speaker, but it's the idea that something is random by nature, and entropy is the item from which you generate this randomness. So it's the sort of chaos part of nature, I guess you could call it. So as long as there is a form of chaos, that's basically what entropy is. Entropy is a form of that something is always different every time you check it out.
Awesome.
I hope that makes sense.
Thank you. That's such a beautiful explanation that I would not have been capable of delivering on my lonesome.
Can I
So there's
also
2
add
things.
something?
Yes, please.
Yeah, so about the entropy. So I guess the contracts have a key value store. So the way you store data is you have a key, and then from that key you can find what value contract is storing. And to generate random numbers, what we have is a random number generator. And that random number generator needs some kind of a string or some kind of data to initialize. If you put the same data each time, then the random number generator will be the same. So entropy is a way of providing some initial randomness, and that entropy can be any string. So the reason why it's called entropy has to do with like the idea of entropy in physics, but it could just be called a random text. what we do is take that entropy, add some block time on it, add some other parameters on it, and then use that as a starting point for the random number generator. And that random number generator gets updated each time someone does an action that uses it. So let's say I want to randomly generate a viewing key. So I generate a viewing key in the contract, but I also provide my own entropy on top of this random number generator whenever I do that. So my entropy gets added to the state, to that key value store for the next random number generator to use as their source for randomness. So that's the main idea. The main idea is you're going to add your own randomness to it anyway, but it's a way to start randomness. Yeah.
Thank you,
Yeah.
Simon.
Good on you for adding the implementation. I thought I'd leave that out though. That's exactly.
Yeah. And I just want to say, like, something that's so cool about being a part of this community is, like, I'm based in New York City. I think Sandman is in Turkey. I'm not certain. And Ertemann is in the Netherlands. A lot of Secret Network is in Israel. Like, it's truly a global community. And it's so exciting that, like, all these brilliant minds are able to come together and just like I started knowing nothing when I joined, and I haven't been here that long. And it's just like the knowledge just compounds because everyone's so willing to share. And yeah, it's just exciting that we can do this together today. Okay, so just really quick before we jump into the state, I want to just make note of that. So we have this entropy, and we know what it means now. You could, if there was a pop quiz, I believe all of you would pass with flying colors. What I added here is just this crate and the state crate, and then this card struct. So all that that's doing is importing the card that we're going to define in our state RS file. And the way you access that card is through something. This is just Rust terminology, importing that state.rs crate. And then secondarily, what's important to know is we're using CosmWasm STD and specifically this address variable. So this is just a human readable address, which means that, like, when we go to query a card, we're entering just that user's wallet address. That's what this ADDR variable is. And the way we import crates in Secret Network smart contracts is through the cargo tuml file. So these are all of our developer dependencies. So that CosmWasm STD, that's coming from this package. And just something to make note of to anyone who's a new developer is, like, this stuff changes all the time. Like what we're doing right now, like if you're in this workshop, you are like on the cutting edge of what is happening in the privacy space in Web3. So changes are being pushed, dependencies are breaking, and the information a lot of the times isn't like publicly accessible to the broader community. So it's like the best thing you can possibly do for yourself is get involved with the developer community. Like join the Secret Network Discord, because that's like where whenever there's a new dependency update, that information is pushed there and developers are the first to know. And then we're able to update our contracts. And trust me, you want to know that I've like wasted hours, not like something is not compiling. And then literally all I had to do was like npm install the newest version of secret.js. Okay. So now let's go to our state. So again, like Sam was saying, this is like our key map storage. This is where all of the data that we're creating on in the contract is actually stored. And our contract is as stripped down and simple as possible. So really all that we need is this card struct. And for the purposes of this demo, I just made it a name, an address, and a phone number, but you could include any number of variables that you would want. And from here, what we need to do is create a variable, a state variable for the actual cards that are linked to user wallet addresses, and also a static variable for card viewing keys, and then also our entropy variable that we're going to use to instantiate the contract, and then use when we use the random number generator for the viewing key function. So that might sound like a lot, but it's actually just like 3 super tiny variables. So, and when you create these static variables, I don't know why this is, but it's just kind of what it is. The kind of like formatting is just to use an all caps variable name like this. And I think if you don't, even the Rust compiler will like complain at you, but still let you do it, but say, hey, mister, please make this capitalized. Yeah. And I started with JavaScript and then found my way into Rust, which was pretty scary at first, but then it was like a truly loving relationship. 'Cause if you haven't worked with Rust before, the compiler will just throw 5,000 errors at you, which can be scary, but it's at the end of the day, it's loving. It's like a mother who doesn't let you leave the house until you've like cleaned your room and washed your face. And then you're grateful for it, even though it's annoying. Okay. So this is our user cards variable. And note, we're creating a key map, and the key map is mapping a U8 to a card. All right. And see how it says this is an unknown word? That's because we are pulling this from the secret toolkit, which I don't believe is part of our cargo toml file yet. So we're going to add that in a little bit. That just means that we have to add the secret toolkit as a dev dependency so that we can access that repo, which we will do. And so all you need to do to access that is just say, use secret toolkit. And then the variables that we're going to be using. So key map. And we also have a static variable for our card viewing key. Which is, again, just another key map. And this time it's just a string. So that the viewing key that we end up generating is just a string. And when we create it, it's then associated with a true value, which we will see when we actually write out that function. Okay. And you guys can still hear me, right? It got awfully quiet.
It's a bit weird seeing you using the key map without importing it first. I think it will be like Rust will autocomplete everything for you if you just use if you import it in the toml file.
Okay.
Something like
That's a
this. I
great.
put in the chat. Yeah.
Okay. Sorry. I'm not monitoring the chat. I'm just like full sending this. Let me import that. So I'm just going to paste it in, guys. You don't have to watch me type in along. So cargo toml. Okay. All right. So like, yeah, just note like this tag feature, this was just pushed like 2 weeks ago. So if you didn't have this, then your dependencies might be broken as of like 2 weeks ago. And we're going to be accessing specifically the storage aspect of the secret toolkit. Okay.
Yeah, I think there's another mistake. Your Rust is complaining, but I'm not sure if it's complaining because of the other issues contract.rs has, or if it's because what you imported. But I feel like there might be some dependency issue with the way you imported it, just because I'm not sure that there might be some conflict there. Maybe, yeah. I'll look at it after you finish everything else.
Okay. Yeah. when I ran through the test, I got everything to compile. So I think we should be okay, but we'll come back to that if it turns out to be an issue.
Great.
Um, and then Sandman, while you're here, could you just tell our audience like why we add this B? Because this was like so weird to me when I started,
Right.
like what this actually.
Mhm. So the idea is that so Cosmosm uses, as I said, key value store to store data, and the idea is that the data stored should be uh, uh, serialized, as in binary, and also the data, the key itself has to be uh, in binary as well, or in bytes in this case. So actually, what he's putting in there, he's not putting a string inside that key map. That is a byte. So when you have a string and in front of it you put b, it just turns it into bytes. So it's just converting it from a string into bytes. That's all that's doing. Yeah.
Thank you.
So
Yeah.
so
Who
yeah.
would
Okay.
have thought?
Yeah. Um. Yeah. That's why the new dependencies you put are going to work, because if you go back to it,
Mhm.
the dependencies, notice that you've changed Cosmosm std and Cosmosm storage. Before it was just a specific version, but now it's using the Git version. So
Right.
right, in Rust, if you don't specify if it's from Git and just put a version, it goes to crates.io and finds the correct package there. And as of Secret Toolkit 0.8, Secret Labs stopped pushing these to crates.io. So you have to specify Git for the future versions. And that also goes for Cosmosm storage, and Cosmosm std for the secret versions of them so far. So uh, so if you had the Cosmosm std or Cosmosm storage from crates.io and you had the toolkit from Git, it wouldn't work. But now they're both from the Git, it's gonna work. Yeah.
Yep. Uh, yes. And so, yeah. And that's just, like I said, these sorts of things, like they change so frequently. So like the template that I pulled from, it's a pretty active template, but like they just haven't updated their dependencies in the past few weeks, which is why having this new secret toolkit dependency would break when in combination with these other dependencies. So that's just something to make note of. And then if like you run into the errors, just ask questions on Discord, like in the secret dev issues tab, because somebody has run into the issue for sure and they will help you. Don't feel like scared to ask questions. And yeah, Ertemann or Sandman, if anyone's asking questions in the chat, I'm not monitoring it. So just feel free to answer questions while we code.
That's what they've been doing. Then. Okay.
Awesome. Awesome. All right, guys. So
Just for quick context, by the way, in the end, people can just pull the sort of almost finished code right from the GitHub later on.
totally. Yeah. I could even push this finished repo if people want access to that as a reference point. Like that's probably best. We could publish it to YouTube or something. Anyways, yes, all the information and knowledge will be yours. All right. So we have our MSG.rs file. We have our message file. We have our state file. Now let's write our contract. So this is untouched from the counter. One thing we're not going to be talking about on this tutorial is tests, although we will do kind of our own basic version of testing with secret.js. But if you want to learn more about unit testing on Secret Network specifically, just refer to the Secret Network docs. There's these getting started developer documents where we have information on unit testing and integration testing. All right. So I guess let's just start with our instantiate function. What to note for this, all we have to do is instantiate the entropy. That's our instantiation message. So we can really get rid of a lot of these guys. I think all we need is to say that the response is okay. and to add this entropy variable. So something lovely about Rust too is like I start typing entropy, and then it's going to also, when I use this variable, import this crate from our state. I love how that rhymed. So now if I look up here at our state variable, we have entropy. It just automatically imported that for us. And we want to save to our contract, which is just a basic storage method for saving information to the state file. Storage. All right.
So go back to the state. Let me see why it's saying that.
I think I said save it again, and then it went away.
Right.
Yeah. I love you're adamantly looking out for me. I appreciate it. So if this is your first time developing on a CosmWasm smart contract, maybe this looks foreign to you. And these are parameters that we pass in to our instantiate and execution messages. And they each are referring to something else having to do with the blockchain. So this actually, Steven, do you want to just do a quick dive in of what
Sure.
these four variables are?
So, so entry points to these contracts come with some kind of dependencies, some kind of parameters that are passed down from actual blockchain. So blockchain is written in Go, and it's kind of passing down some information to the CosmWasm. So these four are basically information passed down from the blockchain. So what dApps do? dApps stands for dependency. So it has a ton of things that you might find useful. So storage key value, the storage key value is stored in there. So for example, it has storage in there. You use storage to access the key value pair. So if you needed something from storage, what you would do is you would say depths.storage.get, and then you put the key. Okay, so that's what depths is for. So you can add storage in there. Also, there's other things like API, which are like you need to verify someone's address is a valid address. Depths would also have that for you. And there are some other things you can look at. Environment is the information about the current state of the blockchain, such as the block height, the block time, so exactly what time it is, and about the current contract. So what's the address of the current contract? Yeah, I don't know if it has a contract hash yet. It also has that. So contract hash in there too. So what's the code that the contract instance is using to execute these things? The info, so the message info is for the in the original blockchain, there was a sender of a message, and it's basically checking who the sender is and if they've sent any coins in the blockchain level, not in the contract level. So in that case, it's checking if is it have any secret associated with this transaction, and also if it's also basically. Wait, can you go back to info? It's like who the sender is, right? Is there anything else in there?
Yeah.
Yeah, and the
Uh-huh.
message is the specific message sent to the contract itself. Yeah, there's just sender and funds. Yeah. And then the
Cool.
message is just the whole instantiated message is wrapped inside a transaction. So that's just unwrapping that message. Yeah.
Yep. And this is just what we're importing from our message file. So this instantiation message, we're just importing that here. And then same thing with when we do the entry point for our execution message, we're just pulling the execution messages from our message file. And then same goes for our query. All right. Cool. I'm just so curious, like where everyone's coming from and what this information feels like right now. Cause I feel like if you're, must feel like a lot. So let's write out our execution messages. So formerly in the counter contract, there was just the increment and the reset functionality, but what we have is our create, our burn, and our generate viewing key functionality. So let's just update accordingly. And these messages in the contract file just have to match the messages that we define in our message file. So in our message for create, the create message takes a card and takes an index. So, which that just means that this in our contract file, we just have to make sure we're also referring to the card and to the index. And then what we're going to do is when we execute this message, it's going to execute a function that we're going to define. So right now, this increment function is written right here. And we are going to write our own function to create a card. So let's do that. And it takes a lot more than just depths, because it's also going to take the message info and any variables that we define that we need. Those also are going to be passed into that functionality, into that function. Burn. And we set our burn function. We're just burning a card at a specific index. So try burn card. And we just need the environment. And do we need the info? Oh, we need the index. Okay. And one thing to note is because this function is going to take the environment context, that means you see how up here, this has a little underscore. That means that previously we weren't using this environment variable. So if we are using it, we remove that underscore. And likewise, if we weren't using info, we would add that underscore. Generate viewing key. Cool. Takes an index. We'll probably just go for 15 more minutes here, 20 more minutes, and then we'll take a break and then maybe go into these breakout rooms so that we can just get some water, stretch our legs. All right. And that should be what we need. And the reason why this is throwing these errors right now is because we haven't actually defined these functions yet.
So I will give you a hint to not throw these errors. It's useful. So for example, select that try create card function. Wait, actually, why is it giving the error? First of all, did you create the messages in the message address?
Yeah, maybe they're not imported yet.
Yeah, it doesn't look like they're imported. So maybe just
import yeah. Them. Okay. So we need it. Response. And one other thing we're going to do.
It just, yeah. It did it. Yeah, go ahead.
Okay.
Cool. So what I was saying was to not get these errors, you can do several things. One of them is select that try create function in the message. Try create card. Yeah.
Right here.
Select that. Yeah. Yeah. One thing you can do is select that whole function, delete it, and write to do.
To do.
Yeah. Just delete the whole thing. You can put it back later. It really helps me when I'm developing in Rust. Just
you mean this whole line?
No, just the function, not the first part. Yeah.
Just this.
And say to do.
So you'll just
no, don't comment it out. Just say to do. Just literally type to do.
Yeah. So just delete this whole thing.
Yeah, delete this whole thing. Right, to do. Then complete that. Yeah. And save.
Save.
So that will
Oh,
stop
nice.
compiling, complaining. So you can do this to whenever you need to do something next. So instead of doing that, what you could do is leave that function there, immediately implement the function below, and leave the function body as to do, and that would also stop complaining. If that makes sense.
That's cool. I did not know that.
Yeah.
Yeah.
So that's how you don't get the red errors mid development, and you can see everything. Yeah.
Okay. I'm just going to leave these here for now, just so we understand kind of like the structure we're building out. But that's a super cool tip.
Yeah,
I
you
did not
should
know
leave
that.
them there probably, and then actually do that to-do trick later inside the function body because you didn't implement the function body. Yeah.
Okay. All right. Let's create our card. Um, do we? Yeah. Maybe this would be a good place to take a. Yeah. So I think what we'll do is create our card functionality. Yeah. Let's do this. So I'm just going to comment this out, I think. Can I use this? Yeah. Okay. Let's do this. Try create card. And again, to note, our create card function, it takes a bunch more variables than just like what the increment did. So it takes more than just the depths. It also takes our message info. It takes card. And then note again that it's going to import that state that create for us. And it takes an index. Okay. And we really don't need all of this. Okay. Let's do this. So now what we're going to do is create a card. And what we need to be able to do is associate the user's wallet address with the card, right? And then be able to store that card with a unique index to storage. So the way you do that on Secret Network is we access that user cards variable. So this is what we defined in our state.rs file. It's going to import that for us. So we need to access that. And the way we associate the user's wallet to that card is with this add suffix function. And then what we pass in is the info.sender as bytes. Do you know why we do it as bytes, Sandman? Like, I just know this is how I learned to do it, but I don't actually know
Right.
the logic behind it.
So let's go back to what user cards is. User cards is a key map, right?
Yep.
Yeah. Okay. So let's just on this page for a bit. I will explain what's going on. So as I said, in COSM you have key value pairs, and every time you need to get something from storage, you need to tell it the key, and then you get the value. So what these key maps and items are is the abstraction on that layer. So for example, what entropy is doing is entropy is just an item. That's basically item is basically just storing that key, which is entropy. And it's saying that the type of that thing should be a string. So what that means is instead of having to write the key, which is entropy each time, we can just use the static entropy constant to just load and save whatever is there. So user card is a key map, and which is a more complicated kind of abstraction. What we are doing here is now we go back to contracts.rs. I will explain that. So in this case, what he is trying to do is have a new key map for that specific user. In this case, it's the sender. So what he's doing is he's adding to the key inside of user cards a suffix. So user card's key was user card, so that defines the key map. But he's saying he wants to define a storage object for the sender. So what he's doing is he's just literally concatenating 2 bytes, which is 2 strings, right? So because all the keys are bytes, what add suffix does is it takes bytes and just appends it to the end of the other byte. Yeah, so that's what you did when you said add suffix. You created a new key map that has the key from user cards plus the key from the sender. So now you basically have a new storage abstraction just for that user, essentially.
Awesome.
Yeah.
Yep.
Yeah.
So yeah. And then after we create that storage abstraction for this user with the add suffix method, we then insert. What this is doing is just saying, hey, state RS file, save this card associated at this unique index and have it uniquely linked to this user's wallet address. And that's the reason we have to pass in this message info variable, is that way we're able to access the user's wallet so that we can uniquely link their wallet to this card. I say, let's maybe take a 10-minute break here. And then when we come back at, the clock just changed, I'm in Eastern time. When I come back at 2:18, what we'll do is go into breakout rooms and work together to create the burn card functionality. Does that sound okay with everybody?
But yeah, maybe just
Awesome.
that looks good. So what he did is a key map is basically like he's just inserting a new object there, right? So you're inserting for that user an index, and in that index you're storing a card, right? Yeah. Okay.
Yep. All right. So I'm just going to post in the chat. I'm just going to say, hey, we'll be back at 2:18. Oh, you guys are all in New York time. It's so coastal elite of me. Just come back in 10 minutes. All right.
Okay, see you all in 10 minutes. Make sure to have the code open.
Yeah. Are you also
It's
leaving,
great
Conrad?
news.
No.
Okay.
I'm here through the
I'm
remainder of the
gonna.
workshop.
Yeah, someone's mentioning that the contract, I guess the GitHub repo is not finished. Like he points out that, I think correctly, that if you go to contract.rs there, your whole execute is just commented out.
Right. We will post. I'll push the finished contract. I just wanted like a template in case people were following along to just like have the pieces already built. But the what people have access to right now, that's not the finished product.
Right. Okay.
It's just for this live workshop, so that all you guys who are here get the good stuff.
I might have
It's
to
just
leave
so
for
that
a
you
second part.
can-
Okay.
It's just so you can clone it and then get it into your own VS Code and start finishing the functions. Call without the execute and retention and stuff.
Yeah. I recommend using to do for that. I think it's easier to search and doesn't also create errors. If you are interested in what to do is doing, is to do is basically the same thing as panic. Yeah, it's basically the same thing as panic. There's not that much to it, but it's set
Got it.
because the contract can compile, and whenever it runs into a to do, the whole thing panics and yeah, it crashes. But it's a good tool to remind yourself what to do. Yeah. Yeah. Have you done a poll of how many people are already Cosmosm developers but not secret?
No, I don't think we don't have that info right now. I was trying to ask up top, but everybody's pretty shy.
Some people are typing. I'm curious to see it because they might be curious about why we are not using Cosmosm Storage Plus and instead using Toolkit solutions such as Keymap and And yeah, basically key map. Item is the same as the one in the Cosmos storage plus.
Mm-hmm. Is your answer, is it just iterators? Is that the answer?
That's the answer. There's no iterators in secret, so you have to implement custom iterators. Yeah, that's the answer basically. In the past, there were also some dependency conflicts, but they are not there anymore. But it's just iterators basically.
And we have so many questions, John.
That's like great. What I love to hear. Just
Why
like
can't I
everybody,
move a card from the States?
why what?
Yeah. We were trying in preparing part to just remove it, but seemingly there needs to be a lot more done.
Let's see.
You need to check first if the card even exists before you can actually remove it.
Right. Yeah. Again, like we didn't have all the answers going into the breakout room. So it's more just wanting everybody to be thinking through sort of the steps of what would be required. And it's not always intuitive at first, but like once you start to understand more of the steps, like you have to first check that it exists, you have to load that card, then and then remove it. Like these things, they start to become second nature once you start to become more aware of the processes. But welcome, Secret Squad. I'm glad we're reassembled. So in the meantime, I was trying to just do more for the contract because we're starting to run out of time. So let's just go through this really quickly, and then we'll go to the query functionality, and then we'll get going with the secret.js portion of this. And I don't know if we'll have time for a breakout room. It might be maybe more beneficial at the end of this to just have a larger discussion together. But all right, so everybody can hear me now, right? And we're back.
Yes. Yeah.
Love that. So yeah, so for this burn card functionality, the first step is just checking that the user actually exists, that like there is a wallet address that is associated with this card. So when we create this user exists, we're accessing our user cards variable from state, and we're declaring this new variable user exists, and then initializing it to the value of user cards. Add suffix. This is just the key that is derived from the sender's address. So it's ensuring that the wallet who created the card is the wallet that can then remove the card from the contract, because we wouldn't want it so that like, if I create a card, I wouldn't want Ertemann to be able to remove my card with his wallet. So this just checks that my wallet was the one to add this card to storage. And then if so, we're able to remove that card. So this functionality just checks that my wallet was the one to create this card. And then if it does, that's what this sum none, this match statement, we're able to, then if it does, we just say, okay, for that wallet address, remove that card at that particular index. So because we created the card and it's associated with the user's wallet address at a particular index in storage, we then need to be able to also access that key, which is the index, to remove that card, to burn it. So it's just loading the user, getting their information, and then if that user exists, saying, remove the card at that key, at that index key. And if not, do nothing. That's what this map is.
These dot add suffix and these dot remove, are those like methods of Rust, or are those methods of secret as a network?
So, good question. That's a great question. So if you just like hover over methods too, then it'll give you more information of like what it's actually doing if you want to go into the nitty gritty. So add suffix and remove, as well as get, are all components of secret toolkit storage. So this is just because these variables, we save them with secret toolkit storage in state. We're then able to call these methods to retrieve that variable and then to be able to remove that variable. And if you're coming from like traditional CosmWasm, you would just, there's similar things like this in CosmWasm storage or Wasm Plus, but this is just the secret toolkit version of these methods.
Yeah, cool. So it's not native to Rust, I guess, in that sense, but there are I guess, functions of this.
Right. And I think like if we were to like, can we open this? Yeah. And this is what's really fun is to actually be able to like go into the secret toolkit and see what this functionality is actually doing. So like when we go to remove, this is all the stuff that method is actually checking for, which is scary. I'm glad I didn't have to be the one to design this. It's elegant, but yeah, all we have to do is just take this simple remove method and then we're able to access the storage variable. So if there's no further questions, we're like, I can't believe how much.
Can I do one more question?
Yes.
I guess that, is there a reason as to why you combine the elements into cards as a single item rather than pass them separately? So if you go to message.rs,
Mm-hmm.
you are asked to create some codes for the, where is it? For the execute? Yeah, I
Mm-hmm.
think so. And then it says create card, and card references like the structure elements, capital C, ARD, card,
Mm-hmm.
which then has 2 items. So is there a reason as to why you would do it like this? You pass a card as like a single item with 2 variables instead of passing them separately. And then why is index separate as well?
So why is index not part of the card variable?
Yeah. And also, if you click on cards, those are like 2 items.
If you click on card, that just takes us back to state, which is this card struct.
Yeah. And I guess my question is, why would you not pass these items separate? Why wouldn't you pass like name, address, and phone separately and index separately, but combine
Yeah.
3 of them, but not include the 4th?
Why not include index as part of this struct?
Yeah. And why even bother with using the struct instead of passing the variable separately?
This is just the way I designed it. I honestly don't know if that's the best way to design it. Like this is the way I chose. Sandman, is Sandman still here?
No, it's not.
Oh,
And
he's
maybe it's
not.
just
Okay.
it's an nitty-gritty question, but I was just curious as to why we do that. But that, of course, it makes readability easier because you group all the items. So that makes
And
sense. But
yeah,
there's
yeah,
no reason someone would.
It makes sense for me to put it in an object. You could use it as low parameters, but it's not a good style. I would say to put it in objects that's part together. If you have a in complex contracts, you need to separate these structs somehow.
So
Yeah,
yeah,
it's
so
just a
that
style choice, I guess. Yeah.
and yeah, okay. Welcome all
And for
questions.
the user and the in the JavaScript side, it's at the end a JSON, I guess. Or something.
Exactly. Yeah, so that the user is able to create a card at different indexes and then remove just based on the index. Yeah. So let's just keep plugging away so we can get to that part. Let me see. Where are we at? I'm going to import this. So let's just create the query functionality. Now that we've created the create card and burn card, we're going to finish this out with the query functionality, and then we will dive into the secret.js components. So we have the query message again. This is just another entry point, and we just want this message to match our message in our query. So when we return the card, what we're retrieving is this card that's associated with a wallet, a viewing key, and an index. So all of those parameters I pass here, and then we just need to access that in the query card functionality. And then what we return upon a successful response is the card. That's this card response struct. So if we go back to state, that's the reason why, or back to message, I mean, that's the reason why we defined this struct, so that then when we query, upon successful query, we can return that card. So let's do that real quick. So again, what we have to do is first check that our viewing key exists. And I skipped over this part just for time's sake, but let me just take you through this really briefly so you understand like what we're actually loading in our query response. So this is the viewing key function. I have it all commented out so that you can understand like line by line what's happening. And I'll publish this all to GitHub so that everyone who's here has access to this. This is basically just using Secret Toolkit to create a verifiably random viewing key. So this is what generates the viewing key. And then there's also a viewing key function where we're then associating that viewing key with a card at a specific index, right? So this is just generally creating a viewing key, this function, new viewing key, whereas try generate viewing key, this is associating that viewing key with card index. So yeah, so if we look at our viewing key map, this is the variable we created in state. We're just associating the wallet address that is calling this function with this viewing key creation. And we're also making sure that it happens at a specific index. So it's just adding these two components to that viewing key to make them specific to the user calling the function and to the index saved in state. And once that happens, we just insert that for the card and then return the response. So what that means is that then when we go to query the card, we need to, in order to query the card, we have to say that the viewing key is the correct viewing key for that particular wallet address at that particular card index, right? That's like the whole point of this is that and that's what's so beautiful about Secret is we have this customizable privacy. And this is like a very real world example of us saying, hey, I only want certain wallet addresses to access this, and they can only access if they have this viewing permission. So the first thing we got to do is just check that the viewing key exists. Card viewing key. And we do that again, which I feel like you guys are starting to see the power of Secret Toolkit. We're checking that it's associated with this wallet address. And again, as bytes. And then at that particular index. Mm-hmm. All right. And then we check that at this particular viewing key, like if they have the correct viewing key, then we check in storage if the card exists. So they can only access storage if they have the correct viewing key, right? So we say if viewing key exists, that's the variable we just defined, contains, and that's accessing storage. Then we say, and they have the viewing key. Then let's do something, right? If they have this viewing key, then let's do something. So we're going to say, let the card exist. So then the same way we had to load the user cards in the burn, we do the same thing with query. And hopefully, like now that we're doing this again, but for the query, it's maybe making a little more sense. User cards, add suffix. wallet as bytes. And that looking good. And then now we say .get to load. All right. So let's just see. Okay, that's looking a little better. So if the viewing key exists and card exists, then we match the card with the card response, right? So use your cards. Awesome. Again, calling is add suffix method. Sorry, you guys can't watch this at 2 times speed. Hopefully it's like,
Faster.
yeah, we're gonna have to skip over some
Sound good.
parts that
You can
Why
just
do
copy
we need
some of
to
it.
go to it again? I don't understand. So we already checked these card exists.
Oh, right. What am I doing? You're right. So we just say, thank you. You know what? I was just testing if you guys were paying attention.
Okay.
And so you get a secret NFT for paying attention. That's, so yeah, we just say that it exists. So upon the card existing, we return a card. Right? And if it doesn't exist, there's an error.
How does this match work? If it's the first message is called if it's true, or
Yeah. So it's just saying if it contains this, then return the card. Because this match statement is inside of if the viewing key exists. So only if the viewing key exists and the card exists, then it says return a card response. And then if the card doesn't exist there, return an error. Because you might
So,
have the right.
I mean the sum. So the first method you write, you have to name it sum. Or can I call it whatever, get card or what?
Oh, yeah. So what do you mean just like what is
Yeah,
sum?
what's the first method called sum? Okay, but it's
It's an
default.
option type.
Right.
Yeah, it's a default. It's an option type in Rust.
Okay.
Right. And so that's not specific to Secret Network. That's just like to the Rust programming language. Thank you. That's a good question. Grateful to clarify that. So then, yeah, and if it doesn't exist, we return an error. We can just say like,
So this
Card.
match takes like 2 statements, and if it's true, it executes the first one, and if it doesn't, it executes the second.
right.
And then
Yep.
card exists is just some assumption somewhere, right? You defined earlier.
Yep. And then the other thing is that then we just have to check for the viewing key. So then, okay. Is that correct? And we already returned the card response, so we don't need this. Right. Just trying to see why this is not compiling. So if the viewing key exists,
Say let card exists. That all is good. Action card. None. Card is not here. Else. Throw an error. So it's just literally, I think, is that it? Okay. Yeah. So that's the beautiful thing about Rust, right? It's like, it tells you every little thing. Wallet. Okay. So again, this is just another little, it's just saying we don't have this crate imported for address. We imported it into our state earlier, I think, or into message, but we didn't import it into contract. Import that. And I think we should be good to go. All right. So that is our contract. We have the tests commented out. Normally you would want to do unit tests probably, but we don't have time for that today. The next step is to try to compile it. Trying to think if there's any other, we're not using this. I don't think we need this. That'll probably throw an error if we try to compile. What is this saying? Okay. Oh, so what this is saying, the reason this error is because in our cargo.toml file, we named this package secret business card workshop. So that's why the schema is throwing that error. I'm just trying to get this to compile right now.
You really build it from scratch. Whether that's going to work, I guess, is a question.
We'll see. If not, we'll just jump into what I already have working. It's all right. So yeah, and the way you compile a secret contract is just with make build, which if you go to the secret network docs to the getting started portion of the docs, it tells you all the things you need to configure your environment, and this make functionality is one of them. This is just to compile this Rust contract into a WASM script that then we can upload to the secret testnet and instantiate there. So let's see what this does. Wow. Also, shouts out to everyone who stayed for this long. You guys are all troopers and champions. And I hope the knowledge is coursing through your veins. Arvadi.nft asked if I use any VS Code plugin. I think I have I have a Rust Analyzer plugin that I probably added at some point.
Just a small question during the compile, if possible. Do we have something similar in Solidity, not only in Rust?
I'm trying to, it's been like almost like, I don't know how long it's been since I went to compile a Solidity contract. I know it's different. When I was doing everything in Solidity, it was like, I was using like Mocha.js, I think, or Hardhat. That's what it was, Hardhat.js to compile and upload. But
No. I mean about the dApp in general, or some tutorial for the same dApp in Solidity, because it's a little bit hard for me to understand the Rust right now. And it's easy for me to understand it in Solidity and maybe help to finalize my research and just try to the smart
Um,
contract for the blockchain.
currently,
Take
yes, yeah. So I'm like running brain low on brain power.
okay. No, so secret network. Currently, you can only like the only official library you guys supports is Cosmosm, type sure Cosmosm type of contracts, which are WebAssembly codes compiled to Rust. Or sure, the other way around is these Rust codes compiled to WebAssembly. So the only way to launch secret contracts currently is by using Rust. There is no Solidity. There's no EVM compatible, like Solidity compatible contract language. There is someone working on NIM, like NIE and NIM, as a language for contract development, but yeah, Solidity isn't supported. Can you think of them? Yeah. But there are a lot of Cosmos chains actually that do support Solidity because they leverage this concept which is called Ethermint, which is a development framework to build Cosmos chains with EVM instead of with Cosmos. And from those chains, you can still like query or use secret in some ways in your contract. So yeah, if you really wanted, you can check out like FBOS or Carbon or Objective. All of those use EVM code.
All right, so it compiled, but there were unused variables, and the reason is because I forgot that I left this to do function up here. So it would have meant that like we wouldn't have actually even been able to use our create card functionality. That's interesting because I've never used that before. So it's like normally if you don't have this written now, you wouldn't even be able to compile the code. But because of that, it still allowed us to compile even though we wouldn't have been able to use the functionality. So it's just like a little learning lesson. So I just added back this create card function with the correct parameters. Let's just see. All right, so it looks good. Let me just double check this. So this, and again, this is what I was saying about Rust being a doting mother who tells you every little thing, like to say we're not using this variable right here so that we can just provide an underscore. And this is okay. And then it's basically all these state variables. The reason why this is saying this is just because these are just unused variables. So these are just leftovers from our counter contract. So I don't think we need any of those because we're not using Cosmosm STD storage. We're using secret toolkit storage. So, all right, let's try this one more time. Clear out my terminal. And I think for time's sake, rather than like do a deep dive into the secret.js docs in the way we just did with this, with building everything from scratch, I'm just going to pull in pieces from the finished repo for the secret.js so that you get all the information you need. But just for reference, I want to make sure you guys are. So if you just go to secret.js.secret.network, and if somebody could just link this in the chat, this is all the information you need to be able to use secret.js. And it's a little scattered. There's a lot here, but it all exists. And that's the lovely thing about it is that like whatever your question is, it's probably in here. And then if you need more if you have more questions about implementations of it, there's like secret labs repos that show how to actually implement this. And then just ask questions in the Discord. But like literally like what I would do when I was starting out is just like come to this. And then if I'm like trying to figure out how do I just like load my Kepler wallet, for example, here's like table of contents with integrations for Kepler Wallet. And then it has all this information for how to like actually integrate a Kepler wallet at a specific chain ID. So like we'll talk about this in more detail in a second, but like what's so cool is like this contract that we just made, we could upload it to mainnet, and all we have to do differently from uploading it to testnet is just change our chain ID and URL. And then we would be able to upload this WASM script directly to mainnet if we wanted, which I just think is so awesome. It's just like, anyways, like magic to me. So it worked. We'll see if it actually worked though. That's what we're going to test now. And if not, that's okay too. So what happens once it compiles is it generates this contract.wasm script. And this is what we're actually going to be uploading to the blockchain. So let's do that. So in order to do that, going to just set up our node files. Actually, we want a folder. So right here, index.js. How's everybody feeling? It's like, is this helpful? Are you guys processing what I'm saying?
There's so much more to see a nerd, but it's very much getting some stuff started in my brain yet.
Awesome.
Rust is just very daunting, to be honest.
Yes. So I'm initializing an empty package.json file. I just CD'd into my node folder. So now we have this, okay? And what we're then going to do to set this up is just install secret.js. So that's all you got to do. npmi secret.js to have the magic to access the blockchain.
So do we have to optimize the contract first, or is it already optimized?
So yes, I would normally run an optimizer script. That's also a great question. Because we're just doing this on the test net, it's okay. But if you're going to upload to mainnet, it's like generally like best practices is to optimize. And all of this information, I just want to plug this really quickly for you guys. Like if you want to have even more like step-by-step introduction to this, in this development tab of the docs, there's this piece on compiling and deploying your contract. And in that you can run, this is what we did, make, build, compiling the code. But then there's also an optimizer script, and you just have to make sure that you have Docker installed and open to run the optimizer script. But great question.
Having isn't only necessary if the contract gets too big.
You know, I feel like if Sandman was here, he would have like a super specific answer to that. I just know for like our purposes, it works. But like, I think best practices is generally you just want to minimize, the size as much as possible and minimize the digital footprint. Okay. So there's one thing that we also need to do to compile our package.json file. And I always forget this. It's just making the type module so that we can have import statements. So save. And I believe that's literally all we need. So just gonna make sure that updates. All right. So yeah, what I wanted to do was go through these secret.js docs and do this line by line with you guys. But I want to save time for just like questions and feedback at the end. So let's just test this out. I'm just going to pull in pieces from the completed repo and just explain that hopefully that's educational. So the first thing you got to do is just, am I in the right? Let me just remove some of this clutter. So now that we have secret.js, we can access it because we have it installed in our package.json file. And we only need two imports, which is the secret network client and the ability to access a wallet. This line of code just makes so that we can access our contract WASM file. All right. So let me just paste in some of these pieces. Give me 1 second to find the files. I'm going to paste in my wallet address, and it has all real money. So you should all steal it from me immediately after this. Just kidding. This is always when you're working with testnet or anything, have just like a separate wallet address that you specifically use just for testing contract purposes. So like this wallet is the wallet that I use for all my testing, so that like if somehow the environment file were ever to be like pushed to GitHub and my wallet were to be compromised, it wouldn't matter because it's just, it's not real money. But this is pretty awesome because like this piece of secret.js is literally just giving us access to my wallet. And then this contract WASM variable is just reading the file that we just compiled right here, this contract WASM. So because we're in the node folder, we just have to step out one directory and then access that. And to test that this is working successfully, we can console.log our client. So this right here is literally just pulled from secret.js docs. All the things we're about to see are, except for the parts that are like specific to our contract. But right here, this sets up a client with my wallet address. So now I should see that like we have access to the secret network client based on my wallet. So like if I just console.log secret.js, it should return this. Let's just run this and see. Yeah, baby. We're in. I don't know if you all feel this way, but it's just like the fact that the blockchain is like just this like living, breathing organism, and we're just like able to access it from our individual keys. It's so cool to me. All right. So we're in. So let's do this. So the first thing we're going to do is upload the contract, and we'll see if this works. I'm going to paste in my... So, oh yeah. And like I said, in the secret.js docs, I was looking at Kepler before, but like another thing you could look for is an upload script. So I just control find upload. And here's an example of JavaScript of how to upload a compiled contract to Secret Network. And so we're going to be doing almost exactly this, right? It's just saying there's a sender, which is my wallet address. It's reading the contract WASM file, which we just defined in that variable above. We have to define a gas limit. And then what it's going to do is return this code ID so that we can then instantiate our contract with its unique code ID. So let's see if this works. So I like to do this just as like a little function that I just then run individually for each piece. And so this is just accessing secret.js, this store code, and it's accessing my wallet, right? And the contract WASM variable, we set a gas limit, and then it's going to console log the code ID. So let's run this and see what happens. We commented that out. All right. Lovely. So what I like to do is just save my code ID as a variable. And Ertemann, do you want to just speak on like contract hashes real quick and how they're unique to Secret Network as opposed to other CosmWasm chains?
Sorry, can you repeat? How secret contracts are different from CosmWasm chains in general?
Or just the fact that like we have a contract hash.
Yeah, so that's very interesting. And I must say, like, some background, I work with Secret Agency, which is a DAO in the ecosystem, and we run a multi-sig that means like some funds from the community. And for example, if you want to execute functions using a multi-sig wallet, you would have to state the contract hash of this function in order to sort of verify that you're actually referencing the correct function on the blockchain. Because Secret, because it runs with encrypted states, like a private state, it has a hard time verifying stuff that's normally sort of accessible to anyone. So a node normally doesn't have any way to verify what the actual block height is, for example, or to verify whether the inputs you gave are actually valid. So inside every sort of contract that gets executed on Secret needs to verify all kinds of parameters because it's not publicly usable. So it has to verify that the block height you're submitting is correct. It has to verify that the contract you're referencing is not a like fake contract. All this kind of stuff. So you can read about it in the documentation. There's like a whole section on like verification for contracts. Recently, Secret Network actually added light client verification, which adds a lot more functionality to basically allow the chain to more easily verify certain things. So now in a contract, you can actually verify that it's happening at the correct time or at the correct block height, which is seemingly something that doesn't seem too big, but it's massive for some of the contract design in Secret. But yeah, in general, there are some interesting like quirks because the state is private, how you need to work with that. But to be honest, to know like the details, you would really ask them with the docs or that's Sandman. I'm sure he knows more about what and why it works on certain details.
Yeah, thank you. That's a really good overview. But that just, because of that, we have this contract hash, which we then use to instantiate the contract and also access the contract. And so one thing I want to just show us really quickly, and again, like the docs are the holy grail, right? So like if I were to look for an instantiate script, then here we go. Here's an example of an instantiation script in the docs. And let me just show you like, so your contract most likely will have an instantiation message, but maybe not always. And if it does, that means that when we instantiate the contract, we have to include that message in our instantiation. So you remember that like we had entropy, right? To say like to be able to generate true randomness. So if we go back to our message file, in our instantiation message, we have this entropy string that we have to include. If someone's mic is hot and they're ferocious typers, which it's an admirable trait. Whoever's okay, so there's this. Somebody's mic is still on. I don't know if you can hear me.
Sorry, it's me.
No worries at all. Sounds like you write on a 1920s typewriter, like Ernest Hemingway.
Like a mechanical keyboard. It's a bit loud.
Okay, so yes, we have this instantiation message, right? And we just have to make sure that then when we instantiate the contract in our JS, we include that instantiation message. And for us, it was this entropy variable, which was just a string to generate true randomness. But like if we were to go back all the way to the beginning, the very beginning where we started to this contract, this is the counter contract. I think that had a different starting instantiation message, which was just a starting count, which means that like if we were to, compile this counter contract, we would have to make sure that our instantiation message just included a starting count. So we create our initiation message, our instantiation message. And these are just certain things we have to include to instantiate, like the code hash, the wallet address, the code ID, our instantiation message, and then a label. So we're just saying this is our secret business card demo, and then there's a gas limit. And if this works successfully, it should return a contract address that we can then execute and query. So let's try running that. So again, I'm just going to run. Contract code hash. So it's probably just because this name is incorrect. Let's see. Oh, yep, I wrote contract hash. So clear. What's happening? Contract code hash is not defined. Oh, let contract code hash. See, this is like why Rust and JavaScript are so different. Like Rust would have just like screamed in my face if that let didn't exist. So it's just like funny navigating between the two. All right. Oh my God. Does anyone else just get like a shot of endorphins when they see a contract address? Just me. Cool. Good to know. So we got our contract address. Now what we got to see is if everything compiled correctly, we did everything correctly, we should be able to execute this contract, which is what we're about to find out. No promises because we were kind of just going fast and furious and we didn't really have time to like air handle. But let's see. So now what I like to do is just save this contract address. And what's so awesome about this is like, y'all would be able to use this contract address and then execute it as long as you just have the address and the code hash. I don't know why I'm saying y'all. I'm not from Texas. All right. So back to the Grail. But here's an example of executing a contract. So this is a message where just like money is being transferred, but it's going to be the exact same for what we're doing, but with just creating a card at our contract address. So let me just paste that in. And we'll see if this works. All right. So let's make a card for someone who's been a superstar today. Let's make Code Monkey. We're going to make you a card. You've all been superstars. But we're making a card for Code Monkey. And we're going to say his address is Code Monkey Street, dude. All right. And so what we're just doing now is executing this message in our contract. So we're creating a card at a specific index, right? So those are the two variables we're passing in, right? Another thing to note is like, just notice how everything is lowercase. That's because this scrt, what this is doing is just renaming everything to snake case in our JSON. So that's important to know because like literally like if this was just like a capital C or like if card was capitalized, this would throw an error. And I don't even know if it would tell us why, which might just be really frustrating if you're new to developing. But so we just have these two things we're passing to our message, which is in order to create, we have a card and we have an index. So we're going to create a card at index 0 and we're going to execute it at this contract code hash. And then we're going to console.log our card creation transaction. And so this is in real time, communicating with the test net, right? Like, and it's using my wallet address. Isn't that so wild? Like, to me, when I first learned this, I just thought it was magic. Like the fact that I'm not accessing like Kepler wallet or MetaMask. It's just, this is my seed phrase. And because of that, I can interact with the secret blockchain. All right. So it said it was successful.
I mean, this is just
sorry.
what Kepler and stuff does in the back end, right? You just don't see it.
Exactly. So like if we were to go, we could navigate through this to have a more succinct log that we're consoling. This just gives us so much information. Like, and I recommend like in your own time, kind of just going through that to see more like what are the components of a transaction? Because it's interesting to look at. But it looks like it was successful. And if it was successful, then we should be able to query this card and at index 0 return card code monkey. In the same way at the very beginning when we were doing the demo with the front end, we were able to return card Conrad. So let's add in our query functionality. Oh, and there's one other part we got to do, right? Which is in order to access the card, we have to create the viewing key, right? That's the whole way the contract is designed. And the way I did this ultimately in the front end was like having, with React, is like having both of these functions happen simultaneously with one call to my wallet. But for this, we're breaking it out into step-by-step components so that you can see just like each part. So to be able to access that card, we would need to be able to have a viewing key for that card. So let's create our viewing key. And so again, this part we kind of jumped over just for time. But this is just calling this generate viewing key function, which when we go back to our contract, that's this, try generate viewing key. And so we're saying when we call generate viewing key, it's using this generate viewing key functionality. So let's make sure this is all. So and so notice that for the viewing key, it's for index 0, right? Because we created the card at index 0. This is making it so that now we have a viewing key so that anyone with the viewing key can access that card at that index. If this was index 1, we wouldn't be able to access the card we just made because that card we created at index 0. All right. So this is our viewing key that we created using the secret toolkit, RNG. So now that we have a viewing key, in order to access this card, like if I just made up a viewing key, like Conrad's viewing key, this won't work. At least it shouldn't in the way we designed the contract, because that's the whole thing we're trying to do here is create customizable privacy with viewing keys. So like if we were to put in an incorrect viewing key and then tried to query now, let's see what happens. And just note that the only difference, like we're using this query contract method, whereas like up here, we're using execute contract. So that's like what's the difference between executing the contract versus querying the contract. All right. So this should fail if we did this right. Wrong viewing key. And it's returning the error message that we wrote into our contract. Where was that? Right? So there's an error because we don't have the correct viewing key. So that's working. At least we know that much. Now let's take the viewing key that we created for index 0 and see what happens. Awesome. All right. My brain is fried. I feel like this is where a good stopping point for today. I hope this is helpful and this is like amplifies your understanding of how to develop a secret contract and then also be able to take that contract and upload, instantiate, execute, and query it using secret.js. We've gone through a lot. It's been 2 hours and 40 minutes. I'm going to take a pause here and take a sip of coffee and just like open up the floor to just like questions, thoughts, feedback, and just, hear what everyone has to say. And thank you so much for just like sticking through this with me today. It's been a real pleasure to be able to do this with everybody here.
Thank you very much. That's great.
Yeah, indeed, it was good to follow. I always seem to have like when I'm working with like databases on a website or something, it's complex to use for some reason because you run your own database, but if you design like front ends or I guess the secret.js applications with a blockchain, it becomes a lot more intuitive actually because you just query whatever info you want. As long as you assign the correct information, it gives you the correct information back, which I always think is very interesting. Honestly, front-end development for blockchain might be even easier than for non-blockchain applications, because you don't have to handle any of the back-end stuff.
Mm-hmm. Just another thing to note is like, so we linked Secret University at the beginning. So if you want to continue your secret development knowledge, I think that's a great resource. I also recommend just checking out Secret Network docs. I think there's a lot there. And if anything's not there and you wish it was there, you have my information now on Discord. So just reach out to me so that we can just try to get the docs to just the optimum level. Because really what our goal is to make it so that anyone can start developing on Secret Network. And we just want to make sure that you have the toolkit to be able to do that. And we're super excited because we're launching our first hackathon next month. And we'll make sure to just like to stay in touch so that we can get all that information to you. But like, I think that's going to be an incredible experience. There's like no better way to learn all this stuff than just diving in with a team and just getting started developing. Like the first hackathon I went to, I almost just worked solo because I was scared that I was going to bring the team down when I was a completely novice developer. But then, we just ended up working just incessantly and it was an unbelievably collaborative experience and we built something we're really proud of. And you just learn everything you need to know because you're surrounded by people who are excited to be building alongside you. So regardless of where you are in your developer journey, definitely try to take part in the hackathon if you can, because I think it'll be an invaluable experience for you as a developer and on your developer journey. And yes, return a floss. I will push a completed version of this code base so that everybody can just go through this line by line and really dig into what we did today.
Shit. Yeah, I really hope to see you all next time. Sorry, go ahead, go Monkey.
Yeah, I do have a good suggestion where to learn Rust. And because there is a place or the Web3 Alliance or where could we learn more about Rust?
Yeah, that's a great question. Because, I had the same, I just did this journey of like it was really secret that made me want to learn Rust. And I'm so happy I did, because now that I'm working with Rust, like when I was starting to write Validity smart contracts, it just felt so insecure, I guess, especially for me as a newer developer. Because, and the difference is that Rust makes it so that like you're checking all your T's and you're dotting all your I's. And what I would recommend, at least what I did for my journey that was really helpful, was starting with, there's a GitHub repo called Rustlings, which it's these interactive exercises that teach you kind of step by step, and you build on your knowledge from like layer 1 to all the way up to more kind of complex understanding based on what you previously learned through going through these Rustling exercises. And if you really attack it, you can do it in like a day or two. But that is invaluable because it's like a practical, hands-on experience of learning Rust. I also recommend reading the Rust book. That's like a resource I constantly go back to. And also, once you just start developing on Secret, like you just start to learn about Rust by working with the network, because so much of it is just using Rust's library.
Post the link, the Rust link, what you just mentioned.
Totally.
I already read some pages of the book, and but I need a place where, how to start. I guess the book it's a real big place, so maybe it's better to get some starting points.
Yeah, I highly recommend Rustlings. It's a great learning resource, and it really breaks it down into like step-by-step pieces so that you feel like you know what you're doing by the time you move on to the next exercise.
Yeah, maybe that's the right one. So if you, so I'm a C# developer, so I guess, the concept of programming is, I know, but it's every language, and especially Rust is, very special, I guess.
Mm-hmm.
It should be easy for a person from C, though. C is also very low level, of course, right? So at least you're familiar with like the kind of system language. I also shared something in the chat which is called Nearest Your Client Developer. It's a small course, also for smart contract developer. Should be helpful in.
Awesome. Yeah, and feel free to just like friend me on Discord, and just stay in touch with the Secret Network developer community. It's a really great place. Like, just everybody's so collaborative, and like if you want, you can join every Monday. There's a developer Discord call at noon Eastern time, which that's just exciting because you're just around other developers and you're hearing what other people are working on and kind of just the state of the network. And it makes it just feel like it's all possible. Like, I felt like such a noob, I would say, and I still am a huge noob, but especially when I started, and just the enthusiasm of the community and just the willingness of other people to help really makes it feel like you can just figure this stuff out and keep going on your learning journey.